So good morning, everyone, to this fourth Laby-GI owner event in a specific way this time with a webinar. Of course, we are all aware we can't meet each other due to the Corona crisis, but let's make the best out of it. We have for today two presentations prepared. I will start with the service experience, which takes about 45 minutes plus. It's not bare service experience. It also contains a few slides about new developments for our compressor technology. We will have a short break or question and answer session, and then we will continue with a presentation from Laby-GI, our head of R&D, and he will talk about latest developments for our oil-free dry running non-loop compressor technology and the results of our 4,000 hours trial, followed by a question and answer session, and then we're gonna end, I hope so, latest by 11:30. Let's do it like this. If you really have questions, you have the possibility to raise your hand. Or you can type something in the chat, and then I stop at that point and I directly answer the question. If not, please note down your question, and we're gonna review and answer that then after the presentation is closed. I think we have enough time for that. Okay. So nothing happens. Why that? Weird. Okay. Okay, good. So I start with the service experience presentation. We have now around about 650,000 operating hours. The regular graph showing where we are. At the moment, we have 64 compressors in service on 46 vessels. Actually, I have to correct the numbers I predicted last time. It was November last year, because I learned that there have been some shiftings in commissioning schedules on the yard. So it's not 69 as predicted, now it's 64. Anyhow, a large population with a large number of operating hours. Laby-GI total running hours, as we forecasted, is 870,000, with almost 700,000 hours running on gas, where our Laby-GIs have shared 650,000 operating hours. And we are proud to announce that we have up to now 4,500 operating hours on 1.5 LP250 running with the dry running sealing technology, oil-free. There will be more information in this presentation about that, and then later on by Laby-GI. The table showing how many hours accumulated as per machine. It's very clear still the 5 LP250 single units are the leading machines when it comes to running hours. There we have completed 6 2.5 years inspections. All of those compressors have about 20,000 plus running hours, and I would say this will be a topic then for the next event to share a little bit more insights of what we have found when we did these 2.5 years services. Nevertheless, also the other systems are ramping up hours, and there are more and more also of these redundant LP190 and LP250 units now in service by end of March. Having a look into how the individual machines are acting in service, we start with the LP190, where we see the heat map. The topics which are of importance for sure is the issue with deflection, or let's say the unexpected wear on the labyrinth stages. We are still claim that we on the way to get green. The rollout campaign or the upgrade campaign for these compressors is almost complete. For the machines in service, we have so far positive results. However, we still keep an eye on the developments around oil in the distance piece. We still have to monitor the development development of the new bearing materials, the galvanic materials, and the WM38 material, which is newly installed on the compressors. And unfortunately, we have now also cases reported from the LP190s with leaking crankshaft seals. This is an issue which follows us on the LP250 for quite some time, and now it turns out that we have similar experience, unfortunately, with the LP190. Reviewing the status of the upgrade campaign for the enlarged piston rod on the 6LP190. We are almost complete. So there are at the moment only 4 compressor units remaining, which have to be upgraded on 2 vessels, sailing vessels. And it was planned that this upgrade will happen within the next few weeks. But unfortunately, you can imagine, due to the corona pandemic, we have to postpone that. Yeah, I would say to unknown time, because at the moment it's not possible to get crews on board. It's already very difficult to manage logistics, that parts arrive at agents. So we have to shift that a bit, but positively said, there are only 4 units remaining out of these 25 compressors which had to be rebuilt. So that is positive. We almost achieved the goal, and let's stay positive that it's just a matter of time that these 4 remaining units will be upgraded as well. Summarizing present service experience with the LP190. 12 compressors are in operation now with the D90 piston rod. The remaining compressors are still sitting somewhere at the yard waiting for commissioning. Generally, the feedback we get from these machines is that they are running well. So far, we get the mainly positive feedback. It's good to hear as well that we get confirmed performance for the types 6LP195D and 5C, which have been intensively tested during gas trials at yard. Tested meaning that there was a kind of performance measurement where we compared required mass flow to actual measured mass flow and shaft power consumption, and it was positive for the specified operating cases. So with the measures taken, we can confirm that we are back on track with this compressor also when it comes to performance. It's clear that we keep the further development of any wear on the piston skirts and cylinder bores under observation. Same with the main center and connecting rod bearings. We agreed there that it should be monitored at least for a period of 8,000 operating hours until we can give a green light that we really can conclude that this upgrade campaign was finally successful. We keep working on the issue with the oil accumulation and distance piece. A few slides will follow there later. And partially, we have claims that compressors cannot be fully operated up to 100% load in certain operating cases due to first stage discharge temperature. This is under observation, and I hope I can give you a follow-up during the next forum then. I will keep you updated. New on the LP190 also are negative experiences with crankshaft seal leakages. There will be a slide later on explaining that in detail. Here a short reminder, this is a slide I actually already showed in November in Trieste for those who were attending. For the 6LP190, there is actually a customer information available. Sad to say that we did not actively publish that back in November, so this is a short reminder. Our ship support will come back to you and explain. The story behind this customer information is that we said we will have visual inspections carried out on this compressor after 1,000 operating hours, 4,000 and 8,000 hours after this upgrade took place. We will have a visual inspection of bearing conditions, distance piece conditions, crank gear conditions, and of course do a detailed clearance measurement on the labyrinth piston stages to get an idea about the status of the machine after the upgrade. Now, this was a bit too early announced in November because we realized there is a lack of spare parts, mainly gaskets, on board of the concerned vessels. So now we will be ready. The parts are available. So ship support will contact you, will deliver these parts, and then you could start with this inspection campaign. A story which is following us now for almost a year is the root cause analysis for the repeated bearing failures of compressor L0173. You can probably remember my first presentation about this topic was in Oslo last year in April, where the compressor, which you can see here on the left side, just completed the first test run with negative results, meaning with wear indications on a number of bearings. So this compressor, in the meantime, was tested about 22 times on our in-house test bed here in Winterthur. It was removed from the specific customer project. The compressor is now currently only acting as a test compressor. Many of the owners have been involved in the test runs which have been done during the past month. All classes have been involved because we wanted to track down the root cause and of course make sure that there is no correlation with compressors which are out in service. So we can close this chapter hopefully, because our root cause analysis brought up some findings. And it is interesting to see that all our intention on the machine itself with changes on bearings, changes on parts, etc., didn't lead to anything. However, later on, we figured out that there is a lubrication issue on this compressor. Actually, you see here on the right lower side an oil sample taken from the shop lube oil system during operation. And I'm not sure if it's visible on your side, but what should be indicated here is that this is strongly entrained with air bubbles. So we figured out that the root cause is poor lubrication caused by entrainment of air in the shop lube oil system. And therefore, at the moment, we can roll out any direct correlations with present service experience on the 6LP190, which are installed on the ships in service. How did we conclude on that? After first indications were present that there might be issues with the lubricating system, the shop lube oil system was modified, and there were some stilling tanks or stilling basins installed in the shop lube oil system. And here you can see on this picture in tank number 1, basically this is the oil coming out of the compressor during the test run. And I always say it looks like a fresh drafted pint of Guinness. So it definitely shows a lot of air being entrained in the oil. We can compare it to the condition of the oil as it is in the tank number 2 when it is already degassed. And that then led to the conclusion that there is an issue not with the on the mechanical side of the compressor, but most likely on the shop lube oil system, having too much air bubbles in the oil, then causing cavitation in the bearing area, then leading to the experienced damages. How did it work when degassing measures took place? The system was modified that this entrainment stops. You can see here on the left side the typical result of a shop test with the original system, where we always had these breakouts on the bearing edges, as well as a lot of scratches on the bearing. And we did this very same test run with a modified shop lube oil system, and the result was that we got bearings out as they're supposed to come out in perfect condition. So we closed this analysis here, at least in Winterthur, defining the shop lube oil system as the root cause. However, the question came up, how is the actual situation then on board of the vessel? So to rule out any possible issues here, a project-specific lube oil system was taken out from the skidders in Korea and brought to our Korean facilities in Busan, where we have also a test bed. A 6LP 190 compressor then was started up, having this project-specific lube oil system installed. A number of test runs have been conducted, and the finding was that with the actual project-specific lube oil system, we do not have issues with larger amounts of air or gas bubbles entrained in the system. And accordingly, the result of the test run was positive. Maybe now the one or the other might raise the question, okay, but why this specifically happened to this compressor? And Burkhardt has in the meantime delivered many of the 6LP 190 compressors. So why it only happened on that compressor, not on others? This is a good question, and the answer is very simple. Most of our 6LP 190 compressors almost exclusively have been tested in Korea, where we have a different shop lube oil system. The test bed in Winterthur is rather new, and L173 is just the second machine passing this test bed. So that's why this bearing incidents or issues did not came up earlier and were only stick to this compressor. Service experience LP250. Here we are still following up the trial with the new Secraflex gaskets on the valve covers to stop the gas leakages. There will be a detailed slide later on. Oil in the distance piece is also an issue on the LP250. Slide will follow later. Unfortunately, crankshaft seal, same as LP190, we have again new cases reported. I think all of the owners now are aware of this issue, and I hope we have a technical solution for that very soon. And as well, there is a number of issues reported with axial bearings, which had to be replaced during the 2.5-year services. Usually this part should show a longer expected lifetime than just these 2.5 years. So this is also under investigation. You might remember the upgrade campaign on the high pressure piston rod packing for the LP250, which was started back in September 2018. I would say I will stop showing slides on this issue for the future, because now there are only 5 of total 34 compressors remaining, where the old packing is still installed. Some of these compressors will go to the 2.5-year service very soon, within the next few months. So it is obvious that this packing will also be replaced. For the remaining machine, I stopped tracking because the packing is on board. It's also just a matter of time until during a planned stop, we can replace this. So I would say we can close the chapter of this upgrade campaign, and keep in mind that almost all compressors now are equipped with these packings. The new packing is installed on the majority of systems now and has accumulated quite some significant running hours. For the time being, we can report that we have faced 2 issues with the new design of the piston rod packing. At least one time, we consider it to be a secondary harm coming from the outside. We found some metallic particles in the compression chamber, and they entered then the packing, leading to excessive wear. The second incident with a high pressure packing is just happened within the last 2 weeks. So it's under investigation. We did not get the parts back to our offices here in Winterthur. I will keep you informed about the developments. However, in general, we have a positive service experience so far with this new high pressure packing. Oil accumulation in distance piece, an update here in, it should be March 2020, not August 2019. Sorry, that's a typo, old slide. We have already announced that we have positive experience made with a setup which is running on the non-loop trial compressor, which actually is a quite simple modification, which you can see here on the right. The upgrade on the machine just consists of enlarged siphons. These siphons are installed on the guide bearings. The guide bearings basically are here installed in this area, guiding the piston rod on the labyrinth piston stages. So with the new siphon design and an improved oil scraper design on the high pressure stage, we have made positive results now on the non-loop trial compressor. And there will be another, at least one or two compressors are selected to get this solution installed. This material will be installed on compressors during the 2.5-year service. We know that these machines had significant problems with oil accumulation in the distance piece during the past almost 20,000 running hours. So we hope that we can see a very fast result of this installation. And then if positive results are repeated, then we would roll out the solution, of course, also on other machines, including the 6LP190, because this solution we consider as independent of the type of the machine. Yeah, how does it look like on the oil-free compressor trial? When we have a look into the distance piece after 4,000 operating hours, we found it in almost perfect condition. Those pictures are real. They have been taken by the crew. They didn't clean the distance pieces before taking the pictures. So we see that there is no accumulation of oil, neither in the labyrinth piston stages nor in the high pressure stages. This is, of course, because there is firstly no oil coming upstairs from cylinder lubrication, which is one part of the problem, but the majority of oil we know is coming from the crank gear. It's oil mist from the lubrication in the crank gear, which is pushed up into the distance piece. With the measures shown on the slide earlier, we are positive that this now can be stopped. And we hope that we can continue having such a condition in the distance piece now for the next 4,000 operating hours. I will keep you further informed about the development of this during the next events. Coming to the status of the oil-free compressor trial in general, where are we today? We have reached our 4,000 hours operating target by end of February. We have dispatched our service engineer on board that during a ballast voyage, these installed sealing elements have been replaced. And the parts are currently on the way back to our offices. But what we can say for the time being, because we already received measuring reports and pictures from on board, the parts looked very good, very promising. Lucy Valère will later show us more details about that in the later on presentation. So the machine was equipped with new parts by beginning of March and started up on 6th of March for a second trial period. And the target is now, after this successful 4,000 operating hours, to go at least for an 8,000 operating hours, which means we will have new results available in about a year from now, maybe around April up to June 2020. Of course, depending on the number of voyages concluded and the utilization of the compressor. Oh, 21, sorry, another typo. Yeah, we are now in 2020 already, so that's 21, yeah. Okay. Here the picture actually of the piston, of this non-loop piston, how it came out of the compressor when they dismantled it. It looks very good. The details will be shown later by Lucy in the presentation, which will start around 10:30. So what does this mean in general when we have a look on the schedule of non-loop technology? We have achieved now our 4,000 hours target. We always said when we have this target achieved, we would be ready for rollout of this technology for new buildings. Of course, this will be still accompanied by further testing. However, technology is available now, and we will also start now focusing on having a 6LP190 retrofitted with dry running technology. Our engineering is almost finished here, and we expect that, of course, with the help of a voluntary owner who is willing to participate in this trial, we could start here around summer 2020 during a gas trial, and then also continue with a 4,000 hours verification phase. An interesting learning during this first non-loop trial, this 4,000 hours non-loop trial, was that after 2,300 operating hours, we got informed that the crew notices a differential pressure high alarm on the 5th stage coalescing filter, which was actually still installed. You remember this filter is usually required to take out the cylinder lubricating oil from the gas before we are entering the PRS. However, in this case, there was no cylinder lubricating oil present at all. Still, the filter got clogged, and the filter element was sent to our offices here in Winterthur, and we did analysis of the particles found. So what you see here on the right side is this is actually the filter cartridge. And when the crew opened the filter, they could see such black dust particles on the bottom of the filter housing. Also, when you had a look inside the filter itself, it was full of this black powder. We did a microscopic and thermal analysis of the material found. It was a mixture of a little bit of everything. A lot of fabric looking like particles, and the thermal analysis of the material displayed, it's not material originated from our sealing elements, because that would be mainly PEEK and such kind of compounds. It was not really originated metallic particles from our system, be it like from the labyrinth piston skirts or from the cylinder blocks. So it is not originated from the compressor. We can see now, because we have additional 2,000 operating hours now since we replaced the filter cartridge, that we do not see the differential pressure on the new filter element further increasing. So somehow we conclude that whatever was accumulated in this filter was remaining in the system from the erection and commissioning period. I think it is interesting to follow up this development, because there are discussions, at least with the yard, if for a dry running non-loop compressor, there are requirements to have filters installed in the system downstream before discharging the gas to the Maggies or into the reliquefaction system, because there are some people, they have concerns about wear particles being discharged with the gas. I think this trial also gives us now a good chance to analyze this situation and to clarify if there is really a requirement for such a filter or not. A technical update, I think interesting, especially for those of you who have ordered compressors, both LP190s and LP250s in the years 2016 and earlier. There have been partially cases reported with systems having difficulties when the compressors are operating in a side stream mode, where a lot of gas is being discharged to the gensets and to the GCU. I'm talking about here gas flows in the range of 3 tons and above. So since we have delivered our systems in a setup as it is indicated here, having a control valve installed, being controlled by a pressure sensor followed by a non-return valve, and then gas is sent into the side stream. So in this setup, unfortunately, since the pressure sensor is installed upstream, the check valve, we do not take the pressure drop across the check valve into consideration when we operate the control valve. That led to situations where when flows reached 3 tons and above, the differential pressure developed that high that there was not sufficient supply pressure to the gensets any longer. How to tackle that? Later systems, they have the pressure transmitter installed downstream of the check valve. So control is arranged in a way that differential pressure is compensated. For the concerned systems now, we have made trials in service with new type of non-return valve with a very low differential pressure characteristic. It's made Retac, it's a German brand. All the tests have been concluded very positively. So this upgrade is now available for owners which are suffering from these issues with genset trips during the high side stream operations. If you are one of the concerned owners, feel free to contact ship support for further information how to handle this case. We consider the replacement of the part can be done by the crew because it's a plug and play. The non-return valve, even it's of different make, it has the same dimensions as the original installed valve and is rather simple to install by crew directly. Gas leakage is on the compressor valve covers. An update here where we are today. Until today, we have supplied gaskets of the new material, this Segra Flex material, to 13 vessels, not knowing now in detail if it is installed on all of these 13 vessels, but the general feedback we have received is positive. However, I have to mention here that our ship support asked me, please remind all owners who are participating in these trials that they give us direct feedback. With the Segra Flex gaskets, you have been provided a log sheet for measuring the LEL readings with the gas detector. On the machine, there is also a procedure how to do the measurement. And in order to really successfully close this campaign and make this now official, we would be happy if we could receive these LEL readings from all of the trial candidates within the next few weeks. Then we can also finally close this chapter. We have received a number of readings from some of you. Thank you to the owners who have already submitted. So generally, the experience with the Segra Flex gaskets is still positive. Coming to the crankshaft seal, which is now concerning both LP190 and LP250 compressors. I have shown this slide already back in November 2019 in Trieste. We are still following up the root cause analysis, and we still separate these RCA investigations into two areas. One of the areas is compressors being affected during the first operating hours. We again had a number of incidents being reported within the first operating hours, so we still consider that dirt remaining from commissioning in the system is the root cause there, harming the sealing elements. On the other side, we also had repeated issues with shaft seals which have been operating longer, 8,000 hours and above, where it turned out that it's either a problem with the O-ring, but also new now with the shaft seal ring elements themselves. So it's a little bit too early to come here with more details. This will be a topic then followed up during the coming owner forums. That was the service experience. And now I would quickly show you a few more slides on what is going on in the engineering offices, in the R&D offices of Burkhardt when it comes to new developments. We have announced that already quite some time ago that we are working on a successor of the Mark II Laby-GI LP250, a model we call Mark III. in detail, it's the LP250V. It's a compressor having a stroke of 230 millimeter with an average piston speed of 3.9 meter per second. Just to compare, the LP250 Mark II is operating on an average piston speed of 4.2 meter per second. Why this is of importance? Because this product will be a completely dry running, oil-free, sealed compressor. And there, Lucy will explain that later again, average piston speed is essential to make the lifetime of the sealing elements, to enlarge the lifetime of the sealing elements into areas required by the owners. We have this compressor available both as 4 LP250 and 5 LP250. Again, in the crank gear, we have the well-known features fully balanced and gas tight. So it's a zero leak gas, as we know it from existing Laby-GIs. First stage of the compressor, you see here, first stage again at end, drive end and non-drive end, is again of cryogenic design, labyrinth sealing system type. Stages 2 to 5, however, will be ring sealed technology, non-lubricated dry running. The combination of both the technologies on this new frame, and that is interesting for all of you, will summarize in an improved shaft power efficiency. I think in the later stage of this development project, we will also put some numbers here on the table. What kind of improvements have been included in the design? What can you expect? There are quite some changes when we look on the cylinder models, for example. We have replaced, for example, the stub end connection, which is in service now with the compressors, because some of you are aware that there have been issues reported with leakages on this, gas leakages on these gas connections. So the new LP250 Mark III will have exclusively gas connections according to ASME standard, very solid flanged connections, no longer the traditional stub ends. And we have shifted the piping connections generally away from the valve covers, making the valve covers easier accessible for valve maintenance. That will, I think, be very well appreciated, especially by the crews. And the new cylinder designs will not require any longer cooling on the cylinder covers, so there will be less piping to be removed, firstly installed and also removed during service activities. You might remember this slide. It introduces the step piston concept. I have showed that also in Trieste. Here on the left side, you see the setup of the high pressure stage installed on the existing Laby-GI Mark II LP250, where we have a 5th stage located at the lower compression chamber and the 4th stage located on the upper compression chamber. Once again, this is possible due to the presence of the piston rod in the lower compression chamber. So if we compare the volume in chamber number 5, it is significantly smaller than in the room number 4. So by compressing the gas, we can then let that act as 4th stage and 5th stage. This is the present technology, which you know very well. Future technology will be looking like that. We will apply the step piston technology. That is not a new development. It is existing on the compressor since I would say more than 100 years. Since there are reciprocating compressors existing, there have been dual piston concepts as well as step piston concepts. Each of them have the pros and cons. We want to apply the step piston concept on the dry running compressor due to its advantages, especially when it comes to the arrangement of the high pressure packing, because with this arrangement we have the situation turned upside down. 5th stage is now on top, 4th stage is now on bottom, meaning that we have a pressure range of around 145 to 100 bar discharge pressure on the 4th stage, acting on the compressor packing, where we have here on the existing design pressures up to 300 bars acting on the packing. So we consider that to be an enabler for longer lasting packing, especially with dry running, to have a longer lifetime of the sealing elements installed. That is the cylinder model as it looks right now for this new Laby-GI Mark III. It's a three-piece design where we have the cylinder block 4-stage on the lower section. This here, basically the cylinder block is connected to the crank gear. Piston rod is entering from beneath. We have the cylinder block of the 5th stage, and on top of that we have the so-called valve head. Now, the question already came up during recent owner forums when we compare these two cylinder designs. What is the height requirement above the compressor? Because there we have limited space available in the deck house. I have here comparable numbers. The existing 5LP 250 requires a room of or a height of 5.65 meters to remove the piston from the high pressure cylinder. With the new arrangement, we will grow by 150 millimeters, which I consider as neglectable. How the service will take place? I made a short step-by-step procedure to explain to you how the new arrangement will have to be maintained. Here on the left side, you see a schematic cross-sectional cut through this new cylinder block. We have the high pressure packing at the lower section. We have stage number 4 piston on the lower section and stage number 5 piston on the upper section. To dismantle that, in the first step, the valve head will have to be removed. Together with the valve head, the liner of the stage number 5 will be automatically dismantled. We can pull the piston from stage number 5, which is here connected in this area. So by disconnecting or loosening the bolted connection here, first stage number 5 piston can be removed, then stage number 4 piston can be removed, and so all the parts are out. Packing still will be removed through the distance piece, and new sealing elements then can be installed. I think that answers the question of the people who addressed that to me back in Trieste. At that time, unfortunately, I did not have yet the detailed engineering drawings available. If there are further questions, don't hesitate later on to ask. For LP250, the new compressor type introduced mainly as a replacement of the 6LP190. We have now sold our first unit. It will be delivered to the yard in April 2021. For LP250, I think important for you to remind again, interesting especially is the spare parts interchangeability with the 5LP250 if installed in parallel. All the green marked areas indicate that the parts are interchangeable. So in terms of keeping spare parts on board, all the compressor valves are identical on all the stages. Piston rod, all stages are identical. Then this includes as well the piston rod glands, labyrinth stage guide bearings, oil scrapers, high pressure piston rod packings, and of course the complete parts in the compressor crank gear. There are still some differences, as you can see here, due to the reduced mass flow of the 4LP250 and to different interstage pressures. The piston diameters itself, they still vary on stages 1, 2, 4, and 5. However, I would consider that as minor if we keep in mind that with the 6LP190 we had complete different requirements for spares. I think I'm still within time, almost, yeah. 1 minute over. I quickly wrap that up before you can address your questions. Summarizing, we made good progress on the LP190 upgrade campaign being almost complete. We have positive service experience since then with the LP190s. We have very good results, important results with our non-loop compressor trial. We have achieved this first milestone, the 4,000 hours. Having here to say we are the first ones doing so. There is no other compressor maker yet having achieved such a result with 300 bars and methane in a maritime environment. We have closed the 5LP 250 packing replacement campaign after 2 years. It was tough time. I have to say, definitely we did not consider that this will take 2 years, but with the learnings of this campaign, maybe next time we can speed up a bit. Number of issues remaining with the LP190 and 250 is still not satisfying, I think. We are all aware of that. There is still a lot of homework for Burkhardt to do. And doing this homework right now with you as owners and your crews having difficulties on board, it's very hard for us. We cannot dispatch crews now. We have to rely on remote support. It's difficult to provide you with spares at the moment due to restrictions also in the logistical areas. So we have to make the best out of it for the time being, looking into a brighter future. But let's conclude. We are on track with the LP190 upgrade and to get well on this type of machine. We will keep further developing and push oil-free technology, because now we consider it after this first successful 4,000 hours. It's proven we can manage it. It's not something not feasible. It's real. We will not lose focus on resolving the remaining issues, and for the time being we try to, of course, to provide the best possible remote support to you. And all I can say now is let's stay calm and stay healthy. I think this is most important what we can do. Short reminder as well before I open the question answer session. You might know that LNGM News Channel, the platform on our website, will be slightly replaced with the new app, the BC Marine app. If you are not yet registered, please contact us. Our marketing then can send you again the link to this Contents app, where for the future our important service letters, market update notes, etc. will be published. Thanks a lot for listening, and now it would be up to you to address your questions. And now I have to open your microphones.
Hi, Thomas.
Yes. Hello.
Hello.
Arvid, it's you.
Yeah, it's me. I'm sitting here at my home office. I have some question regarding the 6LP190.
Yes.
We saw some bearing damage on connecting rod and main bearing during the D90 retrofit on one of the vessels. Have you looked more into this, the reason for this bearing? They look some of bearing material.
Mm-hmm.
Have you seen that report coming from the vessel, you know, on 2734?
2734. Also, I know that recently there was an incident with having issues with the bearings. Now it is always difficult to say what is the root cause, because we had at least one incident where we can clearly say it happened. It would not have happened if the upgrade campaign wouldn't have taken place, meaning the service activities were not done precisely to 100%. The bearing was installed not correctly, and then this led to the damage. Apart from that, I have the excuse I do not know the detail now you're referring to, but let's follow up, and we will come back to you with a root cause analysis, and I will bring that in detail then during the next forum.
Okay, yeah, but this was revealed during the D90 modification. Then was when they discover connecting rod, and one main bearing number 1, I think, had some nasty, what should I say, surface. So
Okay.
it was discovered during the D90 modification.
Okay. Okay, we have passed it to our operation center. I think this is just a couple of weeks ago, or it's just recently.
Yeah, your team is still on board due to this coronavirus situation, but they are completed and they are test running the last compressor.
Okay, okay. Yeah, you see, this unfortunately is a little bit too new, this topic, that I was provided with more details, but we can follow up separately from here, if it's okay for you.
I have also one more question regarding 6 LP190 for the sealing cartridges, 4th and 5th stage. I heard that they have performed far better than the 250, and compressors now have, let's say, 15, close to 16,000 hours. But we still see very good result. But in the future, will they also see?
Was ist das zweite?
Somebody is disturbing the audio channel. Please be aware that your microphone is on. Arvid, you have to repeat somehow. We are disturbed here.
The sealing cartridges for 4th and 5th stage piston. The sealing cartridge. It has performed well, but is the plan for 6 LP190 also to have them oil-free in the future? We have seen good experience so far. We have now 15,000 hours, closing to 16,000 on all compressors.
Yeah. This is a good question. As stated, I mean, we will launch a trial in summer on a 6 LP190. There we are looking for owners who volunteer for this, and depending on the results, the future of the 6 LP190 will also be non-loop. So if you're interested in that, we can say yes. It might be that in a year from now, we would have a non-lubricated solution for the 6 LP190 as well available.
Okay, that's noted. And one final question. The D90 modification, 6 LP190, the delivery capacity of gas, because you have a slightly decrease due to the piston rod increase from 75 to 90 millimeter rod. What is the conclusion that you have seen so far for all the projects being completed?
Yeah. I would say you are operating the type 6 LP190 5D. There we have at least what the test shows, which we have done from with the yard. We have positive results. We know that the mass flow delivery, the capacity is in line with the requirements. What is still pending is when we talk about your two vessels, La Mancha and Rioja, there we have the type 5A. And this one, we still will have a look into it after upgrade. If there are special measures like installing a new type of compressor valves, etc. I cannot say anything there because the machines are not up and running. But at least for the type 5D and 5C, we can conclude that with the special valves in place, we can confirm the capacity as specified, also with the T90 millimeter piston rod.
Okay, thank you.
Welcome, Arvid.
Yep.
This is Nikolai from BW. I'm a bit concerned to hear what Arvid is telling about their vessel and problems after the D90 conversion. We have a brand new LP190 which has exactly the same issues apparently. One main bearing number one was damaged during gas trial, and now after I think less than 500 running hours, one crosshead is damaged. So it's obviously urgent to get to the bottom of this issue, and maybe it's not only on the test compressor in Winterthur that we have lube oil issues.
Yeah, you're right, Nikolai. This is concerning. But let's say that also here, this is a development of I think the last week. We are still waiting for more results. What has happened on this specific compressor? Um, Statistically, that's all I can say from now, is that other compressors, now we have these 12 compressors in service with the LB190. There we luckily have positive experience. Now, what is behind the root cause of the incident you have experienced on your good vessel? That really needs to be investigated in detail during the next few days, weeks, and surely I will follow up with you also here in the owner forums to keep you well aware of what's going on. But unfortunately, it's too early to say anything at all at the moment on this topic. You might understand.
Yeah. You mentioned during your presentations, thanks for a good presentation, by the way, that you had actually done a test on a kind of project specific lube oil system in Korea.
Correct, yeah.
So that would of course be very interesting to know whether that there are deviations, let's say, in that system and the one delivered from DSME in our case.
Yeah. Also maybe what we can say for the time being and what we have experienced with your specific compressor already during gas trial, I think it's worth to follow up more precisely on the quality of lube oil in general. Because here we have seen that we have specified lube oil cleanliness grade of NAS 8, and it was realized that we finally found NAS 11. However, that is something we have figured out is not only on that specific compressor, but in general, which moves a bit this topic more into the focus. Shall we request more periodic oil cleanliness analysis from the owners? Do we have to install higher filtration grades to our lube oil system, etc.? So this is now all ongoing as a part of the investigation. As I said, it's too early to conclude on anything right now. Let's follow up during the next few weeks.
Okay. Yes, we definitely will. Thank you.
Yeah. Thank you. Yeah. Hello, Kunal. You have a question?
Yes, I have a question. Yeah, this is Kunal from Flex LNG. Yeah, so we just had a recent upgrade from the D75 to D90 in the month of February for one of our vessels. Yes. That's 2107, and during the test run, we found many a times that the oil is coming into the distance piece in the Laby stage. 1, 2, 3 sometimes. Yeah. So and after that, when finally your technicians gave the vessel to us back, means after the upgrade, it was fine. But I'm still a bit inquisitive now. It's been a month, 2 months now. I just want them to again check actually in the distance piece whether the oil is there or not. Yeah. So do you recommend actually to open it up and to just check this, because it can happen again, this oil in the distance piece in the Laby stages?
Yeah, exactly. I mean, here it would be great if you, if possible for your crew, periodically do inspections and inform our ship support about the results, because that is a bit what is missing here. Missing is detailed information from the field. why is this topic so difficult to be resolved? And I think some of the owners now attending, they know very well, we have situations where we have two compressors sitting next to each other, where one compressor has significant problems with oil and distance piece and the other has not. Even they are of same type, the same system, the identical installation. So somehow we have an explanation for what's going on in the crank gear, which causes then the oil mist entering the distance piece, but we just cannot explain why it's present in some machines very significant, and in others not. So if you help us there with periodic inspections to have more learnings, this is very well appreciated. And in any case, the crew should be aware that, of course, there is always a likelihood of oil to accumulate in the distance piece, and that's why there is a drain installed. So crews have to really make sure that they regularly manually drain the distance piece. It's a part of the instruction manual, but maybe I have to highlight once more. We expect that every 2 to 3 days latest, you have to do a manual drain of the distance piece to avoid excessive accumulation of oil. And of course, if you would be interested in upgrading your compressor with the next service to installation, as I have shown within the slides, with these new siphons and the new oil scrapers on the high pressure piston rod, please contact us. Then we put you on the list.
All right, I understand that, but you mean why can't you just like, you can like a circular, where you can take out a circular saying that once a month, just inspect take the check the distance pieces in the that would be more, a more pragmatic way of going through this whole because I can just tell them to open it up, but then if it comes from your side, a kind of a circular, then it would be great.
Yes, well noted. I will start publishing a service letter accordingly. I think that's best.
That'll be great, Thomas.
Okay.
Thanks. Thanks. That's the webinar was excellent. It was great learning.
Thank you. So there is one more question. Yes, hello.
At the guest trial. Second address. Hi, Thomas. Hi, Thomas. This is Andreas from Flex LNG. Just going back to the discussion of failing bearings on the LP190, can you shed some light if this is galvanic bearings or white metal bearings?
As far as I know, now when we talk about the incident Nikolai was referring to, this should be white metal bearings.
Okay.
The incident we're referring to, Arvid was mentioning, I have to now guess that it might be galvanic. But honestly, you're challenging me now a bit. I can only confirm in one case it was white metal. In the second case, I'm not pretty sure. But we could investigate that.
Yeah, I mean, it's quite some time ago now. We did the Flex Rainbow of France to do the LP190 piston rod upgrade and did the galvanic bearing inspection. We have not seen any problems so far, but of course we can do an inspection of it.
Also, what I can share with the group is we have on the vessel where we do the non-loop trial, we have a riding engineer installed, or we had a riding engineer installed also during these 4,000 hours. And one of his tasks, apart from taking good care of the non-loop compressor, was doing periodic inspections on the LP190. So we had from time to time a look into the crank gear, we had from time to time a look on bearing shells, and so far we only had positive findings, and this machine up to now has about 3,000 operating hours. I know this is not much, and that's why we concluded we will not let go on this topic until we have on all of the upgraded compressors at least 8,000 hours. And that's why we will send you that service letter with a recommendation for periodic inspections. And let's see how this will develop in the near future. Unfortunately, I based on the present cases, I cannot really tell you more. But majority of compressors is running well. However, that does not justify that we have problems on the one or the other machine. So of course we take it serious.
Thomas, it's Arvid there again. Just to clarify on Rioja Knudsen, this bearing damage I was referring to is the bearing that was mounted when compressor was new. It was revealed when they dismantled the compressor for the D90 modification. So it should be the old type bearing, not the galvanic type, just to clarify that.
Okay. I will let's do like this. We will summarize all the questions raised, and I will try to make a kind of a minutes of meeting later on and share with you all, and we will follow up that.
Okay.
Yeah. Good. Just let's see. Are there further questions? For the time being, I do not see that there are further questions. So we could directly continue with the presentation of Lucie Valère, sharing the developments around dry running sealing technology. I just opened the presentation. And here we go. And why my computer is not showing that properly? Huh. Why do we see that? Okay, now it looks much better. So by keeping social distance, I will move from my chair.
Okay, good morning, everybody. It's really a pity I cannot see you. And it's also a pity that you cannot see me, because after many days of home office, I shaved today. But let's do the best of the situation, and I will give this talk just as a webinar. It's about the oil-free test that we have performed on a running vessel. The ones of you that already have our app, they are aware of the results. So it was published, as you can see here. Just so you can see here the page of our application. I will give you some more insights about first of all, dry running technology, and because we believe that this will be the technology for the future for high pressure fuel gas compressors for LNG carriers. So that's why we think it's worth spending a little time on it. Then I will talk a little bit about the improvements that we have made to the non-lubricated system since our first trial, because the ones of you that remember 2017, we started the first trial with a very cooperative owner, and we had some bad results. We could analyze that and learn a lot from it, and with the next test starting last year, we could solve all these problems. Then I will again give a comparison to our new Laby-GI, the Mark III, just that you understand the differences and why we are very confident that we will not face any issues with the non-lubricated technology installed there. And in the end, I will summarize and give an outlook. Okay, about the oil-free technology. It's somehow, it's always a little bit a miracle how you can just remove the oil from a compressor and it still works. But of course, there is a lot of work behind, and I will just highlight the main issues, what has to be considered to make it work. First of all, we need the right ring material, because this material has to be self-lubricated. and it has to withstand the very high pressures, and it should generate very low heat of friction. So it's a very specific requirement for a material that cannot be found on the market. That's why we develop our own material. We have a laboratory, we have test compressors, and we have very experienced people that develop these kind of materials since more than 20 years. We are very successful, and we have our own portfolio of materials, the persistent materials, that are all according to our own recipe, and most of them are produced in-house here in Winterthur, and we also have the quality under control. I think this is a very important cornerstone of this technology. Next point is tribology. So these materials, they need the right friction partner, and as a first idea, you would think you have to have a very well-polished surface, but this is not true. As you can see here indicated, you need a specific roughness to make sure that you have some of the material of the ring being embodied here in these grooves of the material. So you need a very specific grinding of this counterbody. The grinding is one thing, but then you want to have this structure to be present for a very long time, and that's why it needed a lot of investigation and research to determine the right counterbody. You can see here results of different coatings of the piston rod and the liner, and we have invested a lot to know the advantages and disadvantages of the different coatings available. We work with some suppliers, but also with in-house capabilities, and this is an advantage that we have because we really build the ring material and we also build the compressor, so we can partner these two topics together. Next point are the sealing elements itself. We need rings that are sealing very well, so they have to be tight, they have to be strong, and they need a lot of wear compensation, because the wear will always be slightly bigger than in a lubricated machine. So we have to compensate this wear to make sure that we have a long-lasting sealing system. We also have our own ring types. We have developed them since many years and are constantly improving them. And with this, we can say we are a market leader for the ring designs as well. And in the end, you have to be able to configure a system out of these elements. And here you can see a very famous plot that we always show. You can see here the one rotation of the compressor. You can see on this side, you can see the different sealing elements, and this is the pressure. So during one rotation, you start here, you compress the gas, and you decompress it. So in here, with sealing element 1, you would see the pressure in the compression chamber. Typically, the suction pressure is sealed by only one sealing ring, because the higher the pressure difference over a sealing ring, the higher the sealing efficiency is. So usually only one seals the static pressure, but the dynamic pressure, which in the case of Laby-GI is a 200 bar pressure difference, that is changing 10 times per second roughly. This is like a hammer drill for these sealing elements. So you have to protect them and you have to distribute the pressure load over several rings. That's the main story about the system configuration. We have to make sure that the dynamic pressure is distributed. If not, a single ring would break very easily. So this brings me to the learnings from our first test. We had malfunctions in the oil scrapers. This is something that is easy to fix, but unluckily this was the main problem that we encountered, because nobody was thinking about draining the distance piece, and the oil accumulating in the distance piece in the end killed our dry running system, because as we have stated before, oil in a non-lubricated sealing system is harming the performance and the rings. Then we have had a very high pressure difference over some of the rings that were not supposed to have such a high pressure difference. That's exactly what I explained before. We have to make sure that the dynamic pressure is distributed over several rings. This was not the case in the packing that we have installed. Then we realized that a throttle ring, it's called throttle ring, but in the end, what we need is a protection ring. It was not installed, but we realized it's very important just to make sure that if some rings break, and in a dry running packing, always some rings break because the load is really high, and it's not, it's a natural way of wear for some of these rings that they break in the end. But we have to make sure that the debris of these rings don't end up in the compressor valves. So we need a ring which was not installed. Then we also had a very large clearance between the piston rod and the packing cups. This also allowed these debris to go into the compression chamber and end up in the valves. So we realized that this is a very important property of a pressure breaker ring, that we just have a ring that separates the compression chamber from the packing, where we can have debris, where the debris also don't do any harm, but we have to make sure they don't end up in the compressor valves. So what have we changed? We have installed this ring. I will show a slide about this ring because it's also important for the lubricated packing as well. We have increased the number of trisemic rings, which are the real pressure breaker rings, so the ones that distribute the dynamic pressure between each other. We have increased the number of multi-piece rings. These are the rings that really seal. And we have improved the rings itself by applying finite element analysis, also to make sure that we have made the scaling right, because we develop usually these rings in smaller sizes on our test compressors. And for the big piston rod on the 5LP 250, we had to scale it up properly. So we improved that a little bit, and same goes for the MP ring. Coming back to the throttle ring, this is a new development actually made for this dry running sealing system, but now applied also for the lubricated. It's protecting the compression chamber from all kind of debris coming from the packing. It looks like a ring from the Labyrinth sealing system. It's an endless ring without tensioning device, because we realized that in some instance this spring on the pressure breaker was breaking, and the pressure breaker itself was the source of a problem. So we eliminated the spring, and it's a solid ring now. It has some grooves to improve the sealing efficiency, and it also has some bores to reduce the pressure in radial direction. This is important that in case the ring would heat up, it does not lose the stability and collapse over the piston rod. So we have now a lot of experience with this ring, because it's installed in all the packings that we use, also in the lubricated ones. And we have very good experience with this ring, and it really does the work protecting the compressor valves from any debris from the packing. Coming to the trisemic rings, I said we had an issue that the distribution of the pressure was not good or sufficient to give them a chance to survive. So they had too much dynamic pressure. You can see here a picture from our test compressor, and this is at the very beginning when the rings are new, and you can see here the 100 bar are the suction pressure, and the 200 bar the discharge pressure on our test compressor. So you can see here that only one ring was sealing the whole dynamic pressure. So every line is the pressure behind a ring. After about 100 hours, we could see a very nice pressure distribution. that's exactly the state we want to achieve. But we have not taken into consideration the first 100 hours where the rings have to run in, and during this some of them seal too good, so they seal completely and take over the whole dynamic pressure. And this was the case in our first trial, and this led to failure of the rings, and we have improved the rings by applying a bypass channel, which is basically we have already manufactured them in a run-in state. So you can see that now from the very beginning on, we have a very nice pressure distribution. And also after 100 hours, we can see that this pressure distribution remains constant and is helping to protect the rings and allows it to achieve very high lifetime of these rings. So this was implemented, and as we said before, in July 2019, we started our test on a running vessel just after gas trial. So it was a clean vessel. It was a very fortunate situation that we did not have to clean all the oil before installing it. And it was running flawless for more than 4,000 hours. Of the 4,000 and almost 4,100 hours, we dismantled the sealing systems for inspection. This was pre-agreed that we take it out after 4,000 hours because we wanted to know the state after 4,000 hours, and we didn't want to risk that something damages the rings and we cannot learn something from this test. So we took it out after 4,000 hours and replaced the sealing and rider rings. And now, since about 500 hours, the compressor is up and running again. And we are very happy that during this whole 4,000 hours, the compressor was always available. So we did not have a single incident with the dry running sealing technology. And we also could show that the oil that does not do any contamination of the heat exchanger could be seen in a very good performance of the overall system. We were installing additional monitoring of this packing because first of all, it's a test, and second, we want to be able to predict the condition of the packing to make sure that we can replace the rings in a period where it's no problem. In this specific case, it's a vessel with a redundant system. So on a ballast voyage, it would be no problem to replace the rings. While on a laden voyage, it might cause some problems. That's why we really want to know if the system is fit for the next laden voyage. And with this additional monitoring, I think we have a very valuable insight to the packing. What we have been looking at was pressure inside of the packing. For this, you can see here a sketch of the packing. And we have between the trisemic rings, so the pressure breaker rings, which should take the dynamic pressure, and the real sealing rings, the ampere rings, we have a pressure sensor. Additionally, we have monitored the piston rod temperature, and this is a very valuable indication to see if we have thermal collapse in the packing. So this would be a very early indicator that something really bad is going on. This I don't think is something that is needed to predict the condition. This was more a safety measure for this specific trial. And of course, we have measured the gas leakage flow and gas leakage temperature. You can see here a screenshot from the Prognos system. Down here, you can see the leakage. You see it's not constant. It was varying a lot. This is typical for the sealing elements we have installed. But we can say that from very beginning till the end of this 4,000 hours, it was constant and it was low. So the sealing performance of the packing was very good during the 4,000 hours. Here you can see the leak gas temperature, the piston rod temperature, and this pressure within the packing. This pressure was also varying a lot. this is the accumulated data over 24 hours. If you are looking at in the PV diagram, you can see here the 5th stage compression and decompression in the compression chamber over one rotation of the compressor. You can see here this fine line is the pressure result of this sensor. So this was the very beginning of the test. We can see that the pressure, the dynamic pressure reaching the ampere rings was very low. We could see that with some wear in the packing, this value increased and increased. But still here on the right-hand side, you can see that the value of the dynamic pressure is relatively high, but the gradient, how it increases, is the steepness is reduced a lot compared to the pressure in the compression chamber. And the gradient, the reduced gradient also helps a lot for the ampere rings to survive. And this is also something that we could show in the result of this test. Looking at the inspection of the sealing elements, you can see here a sketch of the piston. Here is the 5th stage compression chamber, here 4th stage, and you can see the rings numbered going from the high pressure to the low pressure. We have here ring number 1 till ring number 6. They are retained piston rings. This means they don't have wear compensation. So they will not wear after a short period of running in, but they are the pressure breakers on the piston. And then we have ring number 7 till number 12, which are traditional sealing rings supported by a anti-extrusion ring. And then we have one additional sealing ring for the 4th stage and the rider band. Looking first at the retained rings, there was no fracture, and these are, as I said, the pressure breakers. So they see the whole dynamic pressure, which is usually a threat to the rings that they could break, but none of them was broken. There was no thermal damage. So this is could usually happen during running in when they still have some wear compensation, that they get too hot, but this was not the case. And looking at the friction rings, we could also see very normal wear behavior. Of course, they wear, but this was as expected. And we could have some negligible harm of the rings basically on the 4th stage where the load is small. So we expect there probably some debris from the very beginning have harmed the rings. But this was not at all in a way that it would jeopardize the operation or the function of the packing. So the result was very good. It's still written preliminary because this analysis is based on a report we have got. The rings are still not in winter tour. So with all the Corona crisis, it might take some longer until we receive the rings. But our field service engineer that was dismantling the sealing system has filled in a very detailed report, and all these findings are based on this report. Going to the packing, we have here the compression chamber of the 5th stage. Then comes our D0, so this is the pressure breaker or the protection ring. Then we have 7 trisemic rings, and we have 5 multi-piece rings, which are really the sealing rings. Here are the pictures of the different rings, and here the trisemic ring you already see broken. This is typically how they break, but they still remain in function, but somehow they seal less when they break, and this also happened here. But first to the D0, so the protection ring, this one looked like new, and it was obviously doing the job because none of the debris from this trisemic ring could enter the compression chamber. The trisemic rings itself, they have suffered a little bit. So 2 of them were fractured heavily. 3 of them were in reasonable condition, and another 3 of them were in very good condition. And I mean, in the end, this is the point where we see some improvement possibilities, but nevertheless, they have done their job for the 4,000 hours, and they have protected the multi-piece rings, because here we can see that all of the rings were in very good conditions, and also the wear was as expected. It seems to be a very linear wear, and this also allows us to do some estimation how long the rings would be possible, could survive under these conditions. Also here we had some very slight deformation, which might lead us to an improvement of the material itself, but this was also in no way somehow interfering with the operation of the compressor. So the primary conclusions of this 4,000-hour test: the piston rings were in very good conditions. They showed normal wear. The packing, there is some potential for improvement, but despite the damage of some of the trisemic rings, the MP rings were in very good condition. And if you look at the wear, here you can see the maximum allowable wear of these rings. These are the 5 MP rings, how the wear was. So in the worst case, they reached less than 40% of the allowable wear of the 4,000 hours. And this brings us to the conclusion that if we make a linear extrapolation, which can be argued if it's valued here or not, but it brings us to the conclusion that 8,000 hours of operation would be realistic. Now we'll just highlight some of the differences between the system that we have just tested and we still are still testing to what we are offering for new vessels with our modified 5LP250B. So this is the existing system. It's basically the lubricated system that we just have turned off the lubrication and of course improved a little bit the sealing rings. You see here the 5th stage compression chamber, 4th stage compression chamber, the piston with its piston rings, and the packing. If you compare that now to the new solution, where we have the 4th stage suction in the communicating chamber here and then being compressed close to the packing. So we compress here from about 40 to more than 100 bar. And the 5th stage up here, where we compress from 100 to 140 to 300 bar. We see that the main difference is that here we have 100 bar static pressure on the packing because the suction pressure of the 5th stage is about 100 bar. And we have additionally 200 bar dynamic pressure on the packing. While here we have about 40 bar static and less than 100 bar dynamic on the packing. So this reduces the load on the packing dramatically. And remembering the results of the test, the piston was no problem, but the packing is a real challenge. So I think this modification helps a lot to increase the lifetime of the sealing systems. If we compare now the main drivers for the lifetime, this is of course differential pressure. So here is the static pressure and the dynamic pressure, and here is the piston speed, because it's also very important, because speed is not something that has a linear effect, but the higher the speed, the higher the temperature. The higher the temperature, the lower the strength of these polymeric materials. That's why it's very important that we also look at the speed. We compare here our test compressor, the modification, so the existing lubricated machine modified to non-loop, and our new step piston design. Our test compressor is operated with hydrogen, which is much more demanding in terms of leakage. So it allows much less leakage to be to require the compressor to be stopped. and we have a lot of experience with this compressor. Usually we don't run more than 2,000 hours with the same packing, but we can extrapolate because we have a lot of experience with this compressor. So we are estimating that on our test compressor, our filling systems for the piston and the packing would last more than 12,000 hours. Looking at this modification where we have, as I said, a static pressure of 100 bar on the packing and 200 bar dynamic, we could show that we reach more than 4,000 hours. But still, this might be the most critical element of this whole compressor, because on the piston, we are pretty sure that we can achieve 8,000 hours and more. Looking at the differential pressure, the dynamic differential pressure on the piston is 2060 bar in this case, and it will last more than 8,000 hours. If we come back to the step piston design, we have reduced the load on the packing dramatically. If you compare these values to the values from the modification, I think it's valid to say that we expect more than 12,000 hours of lifetime of this packing, especially also because we have reduced the piston speed compared to the test we just have performed. On the piston, we also reduced the dynamic pressure. We increased the static pressure a little bit, but also with the reduction of the speed, we believe that 12,000 hours of operation would be possible. So in total, this new compressor, Thomas already talked about it also more in detail. I just wanted to highlight this new product again, because now having all the insights about the dry running technology, I think it's important to bring it back to your memories that we have now this machine that we offer, and it has a lot of benefits, mainly of course the oil-free operation, and also it's more power efficient and the efficiency on the heat exchanger in general, but also of the PRS will be increased. And altogether, we think it's really the solution for the future of Laby-GI powered LNG carriers. I'm summing up. So we have learned from the first test. I think this is very good to see that this test that caused a lot of troubles for the owner that was willing to cooperate with us, at least had a very good benefit, I think, for the whole industry. And we are very grateful that we could test this system for the first time, even though it caused some problems. But we learned a lot, and I think that's very important. And in the end, it was leading to the success that we have now with this 4,000-hour test that we just concluded in February. We see a potential for much more than these 4,000 hours. I think our next target is the 8,000 hours. We will try to achieve these. We still see some potential for improvement, especially on the material selection and also on the ring geometry of these trisemic rings, where we think we can make them a little bit stronger. And as Thomas already mentioned, we are planning some further tests. These include also the upgrade of an existing vessel, so a vessel that already is oil contaminated, where we have to find a way to get rid of the oil in the system. And also it includes the 6LP190, which is a little bit more challenging than the 5LP250. But I think with the results that we have achieved on this 4,000-hour test, we are very positive to also be able to upgrade the 6LP190. And very important for us, especially for new compressors, is the result of these 4,000-hour tests even underline our estimation of the new Mark III compressor, the 5LP250V, with a step piston design that we can achieve their mean time between overhaul, which is in accordance to the market needs. Especially if we can facilitate the maintenance or the replacement of the sealing systems, that probably it's possible in 1 day during a ballast voyage. We believe that 8 or 12,000 hours of lifetime of the sealing system would be acceptable to you as an owner, and I think with this we could offer a very good solution for the market and also for the existing ships as well as for the new ones for the next 20 years. So that was my summary of the results. If you have questions, I'm happy to answer those.
Yes, thank you for a very nice presentation. This is Peter Nierens from Man Energy Solution. I have a short question. Do you consider that the gas pre-filtration, will the demand be higher when running dry compared to, let's say, oil-free compressor? So do we need to consider better filtration of the gas, or do you think we can continue with the present standard?
I don't think this is required. Usually these dry running sealing systems, they can accept easily some particles, because the material that we use can embed these particles, and usually it's less of a problem with a dry running system than with oil, where sometimes particles together with the oil can accumulate and block the rings. With a dry system, usually the particles just go through the system, and since there is not a lot of debris coming in, there will also not many debris going out. So I don't think there is a problem with the dry running sealing system.
Okay, thank you.
Are there any further questions to Luzi?
Yeah, one question, Arvid von Knudsen. We see there has been over time plenty problems with oil and the gas ending up in the gas valve train filters, and that has been a very common problem on Rio and La Mancha, especially at higher engine loads. But this oil-free sealings for 4th and 5th stage piston will, if that is implemented on the this LP 190 compressor, is it expected to solve this problem then, with the oil particles flowing with the gas ending up in the gas valve train filter?
What we can say for sure is it will change it. You know, together with the oil, especially if it also heats up, this oil can form a paste which clogs all the filters. With a dry running system, we might have some particles of the wear, which are usually have a completely different characteristics. We don't expect to have problems, but of course it's still a good idea to keep the filter at the gas valve train in the system. I think that's also why you have a filter there, and but it should not clog that easily as it does today.
Maybe, Arvid, also our experience with the later systems in service is, first of all, for most of our compressors now, we have these coalescing filters installed downstream. And also I know that Electronic changed the size of the inlet filter to the GVT. So by this both measures, I think there is no much more trouble with this clogging due to oil in the systems. This is really something more at the earlier series of gas valve trains and our Burkhardt compressors.
Yeah, Thomas, this gas valve train modification I know about, they are better now than the first model, because the gas valve train filter on La Mancha and Riora, they are exceptionally small and easily gets the delta pressure fiber, which requires changing or cleaning. But one thing, the oil that is now carried over with the gas, can that also come from the first, second, and third stage, being following the gas into being compressed fourth, fifth, and then flow out? It's not only talking about oil leakage coming from the sealing cartridge for the fourth and fifth. There is a kind of combination there. Is that correct? Or?
For these compressors which are really strongly suffering from the oil in the distance piece, we have to consider that also oil is entering from other areas, but mainly the oil is still coming from the cylinder lubrication.
Okay, so mainly from the cylinder lubrication. Okay.
We have to understand here, and this is somehow funny to learn. The 5LP 250 has a daily oil consumption of 3.5 liters because it's equipped with a single high pressure stage. For the 6LP 190, we talk about 6.5 liters because it is equipped with 2 high pressure stages. So you have twice the amount of the oil coming from the LP 190, even though you have less flow. So the oil concentration at the outlet of the compressor is higher. And especially for the earlier series, where we just have installed simple separators, or for some certain systems, nothing, it's a quite high loading of oil which is discharged. But you know, for the later series, also on your compressors, there are high efficiency separators installed. So yeah, I hope that your experience with the latest vessels, with the Adriano and whatever the name is much better.
Yeah, on Adriano and now Traiano coming, it's they are not in gas trial yet, but they will be delivered to this summer. There are some modifications done there to the better, but for La Mancha and Rioja, it's a problem with this oil, especially at higher load, and they need to clean this filter very frequently, and which is very, you know.
But I suggest let's pick that up. I mean, when these vessels will go for service period later, maybe there is a chance that we can modify something to improve this.
Yeah, I would like to have some suggestion on how to improve the situation. Of course, to enlarge the gas valve train filter. That is one countermeasure, but also to reduce the origin of the oil coming with the gas with some extra filtration. And yeah. So if there are any means you see have been beneficial, it could have been, if you could provide that kind of information as a suggestion for improvement for the forthcoming dry docking.
Okay, will do, yeah.
Okay, good.
Yeah. I do not see that anybody raises hands. Is there another question coming from Flex? Because you still have a hand up.
No questions from Flex, Thomas. Except my only observation is here we have to do an intervention almost every year now to change the rings on the last stage to be oil free. But that's something we have to find a solution for then.
Every 8,000 hours seems a bit. It's a bit much.
Yeah, I mean, we are at the beginning of something which was never done before. I mean, at the moment, you know, what we could say is we made a world record. For the time being, it's the first time that somebody compressed 300 bars methane and it lasted for 4,000 hours, and we're positive to reach 8,000. Now, we know this is not in line what you are expecting. On the other side, we also have to say cleaning up your PRS every month is also not in line with what you're expecting. And there are some other areas where we see improvements. So I think in the end, it's a total package you need to consider. On the positive side, you will have by way better improved partial relic system. And by the way, this will have an impact on the total shaft power consumed by the compressor as well, because if you improve the liquefaction on the PRS, you will create less flash gas. Less flash gas is coming back to the compressor. So you compress less gas, you save some power at the end of the day. So in the end, it's not ideal to have these 8,000 hours, but if you look at the total package, we still consider it as a very interesting solution. We are in an initial phase still, and it's a young technology, so let's work on it. But I would say the 8,000 hours should not be the killer criteria to say it's not an option at all. At least from our perspective, it's a very interesting option.
And also, we are trying to make a system or design system that will be very easy to change these rings. So our goal is that the crew would be able to change the rings when required. And then it can really be done in a very short time. And in combination with the monitoring that we can do, we can predict when it's required to change the rings. So we think it can be coordinated with the normal operation of a vessel.
I see, especially the speed of the piston itself is directly correlating to the running hours of the rings itself. Have there been any thoughts about slowing down the existing LP250s?
For the new compressors, we basically have done that, not by changing the speed of the compressor, but by reducing the stroke. So we have reduced the average piston speed of the compressor. But for existing compressors, this is hard to do, because then we would also reduce the capacity. And we don't think this would be worth it. So if you could increase the lifetime of the sealing systems by 20%, by reducing the flow by 20%, I don't think this would be an acceptable solution. But in theory, this would of course be a solution, yes. But I don't think it would be acceptable.
I think the business case is not good.
Yes.
Yeah, exactly. Okay. Wait a second, David. David, you want to say something?
Yes. I'm not sure if this has been asked already, because I've had some issues with connectivity and internet. But with the oil-free solution, what is the plan with Buchar? Is this going to be implemented to the units already installed, or is that going to be not considered?
Also, definitely the plan is, if it's I mean, we said when we finished the 4,000 hours trial, we have proven somehow to you that it's feasible. Of course, the long-term test is still pending, but whoever is willing to go further with us and is interested in a retrofit on a vessel, please contact Tanya from our services, and we will have a look into whatever we can do. The problem is, I have to say upfront, retrofitting a vessel is something which might take a week or 7 days, where the compressor is out of service for modifications in the piping system and on the compressor itself. So we know it's not always an option for you just to do it right now. But definitely, if you have interest, there is always a contact us and we find a way. Maybe Tanya? Yeah.
David, also a few words from our side. So we are working on a detailed technical scope of work. So as soon as we are ready with that, we would be more than pleased to present it also to the interested parties, in order to give you a better and clearer picture about the possibilities doing that. Talking about a timeline, so I think we still need, we are talking about, let's say, mid of this year in order to present a proposal.
Okay, when you say proposal, I mean this should have an extra cost then. It's not part of the issue you have with the oil carryover.
That's right.
As a solution to the equipment.
Correct, yeah. We see that as an upgrade. We do not see that, so as you're saying, yeah, it's a new offering. No. It will be extended within our portfolio, and it's a new offering, yes.
Okay, Understood.
Okay. There are no further questions as I can see. So we are perfectly within schedule. It was an interesting lesson. First time I did such a webinar, but it proved to work out very well, I have to say. At least here on our side, we had good audio quality. We could listen to your questions well, and I hope that our answers have been clear. I will provide you with minutes of meeting where we summarize once again your major questions. The presentation will be submitted to you. It will be online on our news channel and on the new app. There is a recording, which is all of these presentations, which is also available online. So in case, like David said, he missed something out because of connectivity issues, you can do that later on, maybe twice, if you still like it. And yeah, it's a bit sad to say that that would now be the time here in Winterthur that we would have a common lunch and then conclude the day later on with a glass of beer or a glass of wine. It's unfortunately not possible. However, pretty sure these times will come back. I know that there is an owner forum scheduled, LNG owner forum scheduled to Copenhagen for May. Let's see if we can meet there. If not, Burkhard is planning the next Laby-GI owner event for end of August. I really hope that by then this crisis is gone and then we can meet in person. In the meantime, however, just give us a call. We are working in our home offices, but we're still focusing on LNG marine and fuel gas systems. So we are at the end of this session, and thanks again for listening. It's the last time maybe now to raise a hand to address a question. If not, we would stop the session and say bye-bye to you. Nobody raises hands, so I put you on speaker.
Sorry, Andreas here from Flex. Just a suggestion maybe for the future, if you could, along with the physical hosting of these events, could you also broadcast them online? I mean, with a busy travel schedule, it would be great if we could sit in on from wherever in the world we are when you have these forums without being present in Switzerland as well.
We could do that. Yeah, this is a very good idea. We will pick that up for the coming forums. That's a very good idea. Thanks for that input. Yeah. Okay.
Yeah. Hi. Yeah. Hi again. Yeah. This is I slightly differ from the topic which you're discussing. It's basically, you know, some vessels have sometimes reported gas leaks, you know, in the prognosed connections. Mm-hmm. Yeah. And we have just told them just tighten it and then it's gone. So how best we can address this issue, because you know it's happening a couple of times, once, twice, thrice it's happened. So how best we can you know we can address this.
Okay. Prognos is actually somewhere in the audience, but we have to have a look, Kunal, in what type of gasket was provided to you, because what we learned recently is that this connection can be sealed by applying a proper gasket there. I forgot the details. It was a specific type of gasket and a specific material, and we could stop that issue, at least with one owner. So I will follow up with you later on. Let me go back to my office. I have some documentation available. I will send it over to you and you could have a look into it. A very simple solution to stop that issue.
Yeah, all right. Thanks. Thank you so much.
Yes. Fabrice?
Yes, if you can hear me.
Yes.
This is Fabrice speaking. Just wanted to say to our customers, we have indeed some limitations at the moment for sending people to different places in the world. However, our factories and offices in Switzerland are working 100%, as well as in Korea. So our ability to service the marine market for today is still 100% here. So just wanted to say that we are here for you. And keep safe, please. We do as well try to protect employees as first priority, and serving our customers as much as we can in this difficult situation. Thank you everyone for attending. That was, I think, a very interesting way and efficient way to have this this forum.
Yeah, thank you.
Thank you, Fabrice. So yeah, thank you all again for attending. It was not as nice as having you here, but still we had fun, and I hope the information provided suited your expectations. And I would say now bye for now. Keep in touch, stay calm, stay healthy. See you soon in person again here in Winterthur or wherever. And yeah, bye bye from my side. Bye bye.